So let's start. As you can see, we are a little bit late, quite late. So I'm going to try to go fast and see if we can get to lunch at 1:30. And the next session is devoted to speaking to about the stream-oriented unique enabler. So basically, we're going to be talking about multimedia content. We're going to be talking about changing audio, video, and processing audio and video. Okay. First of all, I'd like to know how many among you are planning to use the stream-oriented generic enabler. Could you put your hands up? So okay, not much. Okay. Then I'm going to try to go fast with most of the parts, and then the specific people who are planning to use the stream-oriented unique enabler, perhaps we can, during the afternoon session, we can go deep into the small details and technologies. Okay. So first of all, an introduction. My name is Luís López, and I am associate professor in Universidad Juan Carlos, which is a university to the south of Madrid, around 20 kilometers from here. And basically, my team is working in real-time multimedia communications and multimedia processing, media processing, and I make my work teaching about this stuff and making research about this stuff. And today we're going to talk a little bit about communications, about multimedia communications. And for this, we need to have somehow clear some concepts which are very simple, but I would like to somehow make a reminder for you. In every communication, of course, there is always something or somebody generating information, producing information, and there is always somebody receiving the information. So we are going to be talking about concepts such as the emitter of the information, the receiver of the information, or the source of the information and the sink of information. Okay. And in the middle of the two, there is always a medium which basically is used for transporting the information. Okay. So what is the role of technology in communication? Basically, the role of technology is making distance to disappear. Okay, so if we think about a video conference is not enhancing the communication; it's just making the distance to disappear. Okay, so basically, technology has been used in the context of communication for making distance to disappear. And if you look to the evolution of any kind of networking technology, such as, for example, the mobile networks technology, you can see that the main evolutions are related to the type of information we can communicate. In the old years of 2G technologies, we were able just to communicate audio. Later with 3G, we were able to communicate video. Right now with 4G, we are able to communicate high quality video. And with 5G, it is supposed that we will be able to somehow satisfy all our senses, satisfy our two eyes, so that I will be able to receive a stereo video, 2 channels of video, satisfy my 2 ears, and satisfy even the rest of senses. So this is somehow the evolution of technologies in relation to communications. But the stream-oriented unique enabler is providing a little bit more than just this transport of information. So the model we have for the stream-oriented unique enabler is to transform what you see at the top of the slide, which is that technology is used for making transport. Our idea is that technology can be used for more than transport, so that we can do transport, of course, but we can do things in addition to the transport. We can put something in the middle of the communication so that the information which is being exchanged, the audio and the video, can be somehow processed. What does it mean, processed? It means that we can use, for example, computer vision for detecting interesting things. We can use speech analysis for detecting interesting things in the speech, or for detecting the words that are being exchanged. So this is the main concept of the string-oriented generic enabler, to somehow catalyze this model, to make possible for you to create applications using that model. Okay. And of course, there are many different ways of doing this. There are many different technologies we can use for implementing this vision, but our choice is somehow to combine 3 different types of technologies, which are the ones you can see in this slide, which are basically WebRTC. We are going to talk about WebRTC later, but basically WebRTC are a number of standards providing a standardized and interoperable way for representing and exchanging media information, audio and video. At the other side of the slide, you can see Kurento, which is a media server, which is a middleware, something which is in the middle of the communication, which is going to somehow provide the capabilities for receiving media, for sending media, and for applying different types of processing to the media. And another relevant component of our architecture is OpenCV. So that, I don't know if you have ever heard about OpenCV, but it is a very popular library project, open source, that provides a lot of computer vision capabilities, so that we are going somehow to make possible to integrate in a very simple way OpenCV into our applications and into our systems based on the string-oriented generic enabler. Okay. So we're going to talk a little bit about these 3 components. And the first one is WebRTC. How many among you have ever heard about WebRTC? Can you put your hands up? Just for curiosity. Okay. So you have not probably yet heard, many of you, about WebRTC, but you are going to hear about this in the next few years for sure. WebRTC is an initiative for providing interoperable multimedia communications for the web. This is more or less what is behind WebRTC. Okay. So as you know, there are a lot of different technologies for providing multimedia communications. There are different codecs, different applications, different services. You can, if you think a little bit about it, you can think about Skype, you can think about Google Hangouts, you can think about different codecs, H.264, H.263. So in the world of multimedia communications, there are a lot of different players, but they never were able to agree on something interoperable. So that at the end, that this is something which was hurting somehow the possibility of making applications, pervasive applications, with the capability of interoperating in any device, in anywhere, with any type of network access. So somehow WebRTC is an initiative for achieving this interoperability. And there are very relevant companies behind WebRTC. The main one is probably Google. So Google is probably the company who is making more for WebRTC. But there are a lot of very large companies investing a lot of effort in WebRTC right now. You can find companies such as Ericsson, they are doing a lot of things with WebRTC. Companies such as Cisco, companies such as Telefonica, for example, they are also playing in the WebRTC game. They purchased a company called Topbox, and they are playing hard also in the WebRTC arena. So somehow WebRTC is still a draft. It is not a standard yet, but it is available in many major browsers, in particular in Chrome and in Firefox. It will be probably available in Microsoft browsers very soon also. So around a couple of billion of devices are WebRTC capable right now, okay, which is a lot. Not all devices, but around a couple of billion of devices. Okay. So the message I want you to have is that WebRTC is going to become something important, something very important. Something so important that there are people thinking that WebRTC is going somehow to transform the way in which we communicate. There are people thinking that WebRTC is going somehow to steal the traditional business of operators, that voice and human communications are going somehow to migrate to WebRTC with some time. Okay, and given that we assume that WebRTC is going to be something very important, let's start a little bit discussing a little bit about what is really WebRTC. So WebRTC is a technology. At the bottom you can find a lot of different standards, protocols, codecs, things like that. But which is really interesting is that WebRTC is an API. So WebRTC is something created for developers. WebRTC is not like Skype. It is not a service you can use. It is something that you can use for creating a service. So using WebRTC, you can create a Skype. Okay, this is the idea. So basically, WebRTC is making simple the creation of multimedia applications in an interoperable way and for the web in particular. Okay, so we have evolved from a situation, if you try to make a multimedia application for the web 10 years ago, you needed to invest really a huge effort. You needed to play with proprietary technologies. You needed to make very complex integrations. Right now with WebRTC, this is quite simple. A student in an afternoon can create a simple application for making calls using WebRTC. Okay, and the next natural step is that if WebRTC is putting things simple at the client side, at the browser side, because WebRTC is a browser side technology, what we are providing to this ecosystem is making things simple also for the server side, so that we can put a server in the equation, a server for making things. We are going to understand later what things we can do with WebRTC. WebRTC is somehow a disruptive technology, as I introduced you before, so that WebRTC is making possible to create applications in what people call the long tail. Have you ever heard about the long tail? Yeah, isn't it? So basically, you can create an application for a very specific purpose, adapted to that purpose. So there are people, for example, on last week, I have talked to people making applications with WebRTC for making yoga sessions through the internet, for making notary sessions through the internet, so that you can purchase your house with a notary through the internet. We have been talking to people making some kind of Twitter for recording whatever you want and publishing it into a world. So WebRTC makes possible to create applications in a very simple way, and these applications can be somehow small, just for a small number of people, because the investment for creating applications is not huge, it's small. So you can create an application for satisfying the need of a couple of hundred of people. So somehow WebRTC is starting to be successful in the long tail, but there are people thinking that it is going to disrupt the major communication services in the next few years. Okay. And in addition, WebRTC is a web technology, and as you know, web technologies are somehow very popular. The web community is very strong. Web technologies are somehow simple to understand, and in general, whenever the web has appeared into a specific segment, the web has stolen all the attraction of developers. So somehow WebRTC is opening multimedia communications to the web, and there are people that think, again, that this is going somehow to disrupt these scenarios. So this is somehow our introduction. So we will be talking about a media server, about the Kurento, which is going to provide these advanced capabilities for processing media, and somehow the media is going to be exchanged with end users, and this exchange, we propose to use WebRTC for this. Kurento supports other protocols, other legacy protocols. So if you have some kind of multimedia subphone, you can integrate it with Kurento. But if you don't have that subphone, the difference between creating it and using WebRTC is several person-months of effort. Okay, so our opinion is that WebRTC is, if you want to create your application fast, WebRTC is your choice, is the best option for you. Okay. But of course, you can also integrate with non-human communication capabilities, such as cameras and things like that, IP cameras, city cameras. We will see several examples during this presentation and during tomorrow's presentations. Okay. So once we have concluded the introduction, we're going to start with more technical content. Okay, so we're going to be starting to speak the language of developers. So basically, WebRTC in its initial conception, it is a peer-to-peer technology. This means that WebRTC it has been designed, makes possible to communicate from one browser to the other browser without requiring anything in the middle. You just need the two browsers. Okay. So this model is good for making transport, for making the media that is cached into a device to be transported to other device. But our model is making more than transport. So we are going to evolve this peer-to-peer model to put something in the middle. This thing that we put in the middle, we are going to call it a multimedia infrastructure, or more commonly a media server infrastructure. This is the name that people usually give to this type of capabilities. So our model is the model at the bottom. Okay, so if you go to Google and look for media server, for the word media server, you are going to see that in the market there are different types of media servers, but basically they are capable of doing three things. One thing is transcoding, so that they adapt the media information so that different incompatible devices are able to communicate among each other. They are also capable of making group communications, so that instead of having a communication between one emitter and one receiver, I can have one emitter and several receivers. This is group communications. And they are also capable of recording information and playing information. This is what people call archiving media. We use some kind of mechanism for storing media and for recovering media and playing it whenever we want. Okay. So this is what standard media servers do, and the FIWARE stream-oriented generic enabler is going a little bit beyond. It is providing this type of capabilities, but also it is implementing that vision of making more than transport, so that we are capable of integrating with augmented reality capabilities. We are capable of integrating with computer vision capabilities. We are capable of making things such as mixing, alpha blending. We're going to see several examples about this if you have never heard about this type of media capabilities. And once we have seen this, we're going to start thinking about developing something on top of Kurento, on top of the stream-oriented generic enabler implementation. So for doing this, we need to speak about the APIs. So basically, what we need to understand about the APIs is that our media server is designed for working with models. So there are things that we can define as black boxes. We are not interested in what is in the middle of the black box. And those black boxes provide some kind of capability. The capability of recording, the capability of applying a specific computer vision algorithm, the capability of communicating with WebRTC. So we are going to have different of these black boxes, and I'm going to call to every of these black boxes, I'm going to call it a module or a media element. Okay, so when I speak about media elements from now, I'm speaking about a specific capability. So the point is that Kurento is exposing for you a lot of these black boxes, capable of doing a lot of different things. We're going to see the list later. Okay. And the point is that you as developers are going to create your applications by somehow taking these black boxes from the toolbox and connecting them, so that you are going to create chains of media elements. We are going to call to these chains media pipelines. Okay, so the media pipeline is somehow defining the processing I'm implementing on top of my media stream, so that the stream is going to get through every media element I have defined in my pipeline. So if I put a pipeline which is capable of recording, I will be recording. If after that I put a media element which is capable of detecting faces, I will be detecting faces. If after that I put a media element capable of adding subtitles, then I will be adding subtitles. This is the point, okay? So somehow the Kurento API has been designed following a Lego philosophy. So that you have different pieces and you get the pieces and connect them for creating whatever you want. Okay, this is the main idea. So creating applications is just something somehow where you need to decide which media elements you are going to use and how you are going to connect them. But for creating a real application, you need somehow to decide where you are going to put the logic, where you are going to put the code, which is defining which media elements you instantiate and how you are connecting them. Okay, and for this there are different types of architectures, and we support off the shelf. We support 3 types of architectures. There are additional types of architectures, but which require a little bit of additional developments. In the first architecture we support, basically we have a browser which is speaking directly with the media server. So that the browser in JavaScript, you are going to use the API and you are going to instantiate the media elements and you are going to connect them in the way you want. Okay? So that the browser, given that the browser is speaking WebRTC, we assume you are working with a WebRTC capable browser. As I told you before, Chrome and Firefox support off the shelf right now, both of them WebRTC. So you will be able of creating applications, making that complex processing just from the browser if you want. Okay. This has advantages and disadvantages. We are going to analyze them later. In general, when you want to create a real application meaning an application that you are going to use for making more than demos, in general, it is useful to put something in the middle, to create an architecture with 3 tiers equivalent to the one of the web. I imagine that all of you more or less have developed some kind of web application, and in the web you know that the application has 3 layers: the client-side layer, the application server layer, and the database. Okay, so here it is the same concept. The application has the client side, the application server side, and the database is replaced by the media services. Okay, and here we support off the shelf. We support Java technologies, Java enterprise technologies, and also we support Node.js technologies, okay, off the shelf. If you want to do it with other technologies such as PHP, Ruby on Rails, it is possible, but much more complex. Okay. So this is somehow the main areas, and if you want, given that we have 20 minutes until lunch, we're going to start seeing some examples. We are going to start seeing some real programming. We are going to start seeing some real capabilities. And during tomorrow's session, we are going to continue with the showing of these capabilities, going deeper and deeper on the details of the APIs and on the details of the internal workings of the media server. Okay. So what do you need for starting? Most of the demos and most of the tutorials we have created are based on WebRTC. Why? Because as I told you before, that makes things much more simple. So if you are not familiar with WebRTC, you need to start somehow reading a little bit about WebRTC. You don't need to understand all the details of WebRTC, but at least the philosophy behind WebRTC needs to be understood, and you need to understand a couple of concepts related to what in the WebRTC jargon is called stun and turn, which is basically something devoted to how to manage with NAT traversal. Okay. So I'm not going to make this introduction for you, but I'm going to somehow be speaking about WebRTC details on every of the examples I'm going to show you. So I'm going to be introducing WebRTC concepts during my examples. But if you want really to do something with Kurento, you should read a little bit about WebRTC, and these two hyperlinks I provided you, these are very simple tutorials who have been created by Sam Dutton, who is one of the developers in Google, who is creating the WebRTC stack for Chrome. And they are very understandable. They have a lot of examples, and they introduce the main concepts behind WebRTC. Okay. So this is the first thing you should do. And the second thing is somehow go into the stream-oriented generic enabler itself. And to start with this, you can go directly to the FIWARE documentation through the catalog. You already know the catalog. Or you can go to the website of Kurento. Kurento is an open source software community. So you go to www.kurento.org. You will find all the information related to Kurento. And if you go to documentation, you will find the latest version of the documentation. So if you go there, you will see that the first step is getting a Kurento instance up and running. And you have several ways of doing this. You can go to the file app and launch an instance. There are an image. There are also recipes for Kurento. So you should be able to use them for launching your Kurento instance into the file app. But if you want to have it out of the file app for somehow getting it under your control and not requiring to be dealing with the complexities of the file app, you can also install it into your very own facilities. And for this, you just only need an Ubuntu machine having the version 14.04. And after that, you just need to add the Kurento repository and make the install, apt-get install, and that's all. Okay. So once we have that media server installed, you can create your very first application. And somehow the most simple applications you can create with Kurento, we can call it the Hello World application, is an application involving WebRTC, which is sending a media stream to the media server, and the media server is giving back the stream to the browser. Okay, so that this application is not making anything useful. It's just sending the media to the media server and getting the media back. It's not useful, but it is going to be interesting for you to understand how to program with Kurento. And once you have this application running, you will see that it is now complex to make the application to do more things or to evolve this application for making more interesting things. Okay. So basically the idea is that we are going to have a web part of the application. The application is going to run into a browser, and we are going to use some JavaScript code for asking the media server to receive a WebRTC stream and to send back the WebRTC stream to us. So the first thing you need to think about when you create Kurento applications is, what are the models I need? What are the models I need? In this case, I don't want to make any computer vision. I don't want to make any augmented reality. I just want to send and receive WebRTC streams. So the model who knows how to do that is called the WebRTC endpoint. So I just need to manage, I just need to use the WebRTC endpoint. And the explanations for this tutorial can be found in the web, and also the code can be found into GitHub. And if you want, we can take a look to it. So this is This is the Kurento documentation that you can find in the web. There are hyperlinks from the catalog also to this information. If you go to introducing Kurento, you will see here the main concepts I already introduced you during this presentation. Okay, so, and if you go here, you will have to Kurento Media Server installation. You will have the instruction for installing, okay, and the instructions for configuring stun and turn. This is somehow an advanced topic, and we are going to manage it during the lab sessions with the people who is really wishing to install Kurento. Okay. So once you have installed Kurento, you can go to the tutorials. There are several tutorials, and the first one is the Hello World tutorial. There are 3 versions. With 3 different architecture, with and without application server. Okay. We are going to take a look to the most simple one, which is the browser-based application. And here you have the instructions for installing and running this demo, this tutorial. And basically the tutorial, the application is doing what we have just introduced before. It is using the webcam of the of your device, of your laptop, or of your mobile, because WebRTC is also working in mobiles. If the mobile device has Chrome browser, then you also have WebRTC. And we are going to use the webcam for catching the video, and we are going to send the video to the media server, and the media server is going to give back the video to us. Okay. So what? Yeah.
No, it's okay here.
¿Esto? Nada, tranquilo, no pasa nada. It seems that there are some technical problems with the internet transmission of the session. So it's okay? Okay, perfect then. So what I want now is to show you a little bit of the portion of the code which are in the tutorial, okay? Which are basically these ones, okay? So the API is based on something that we call the Kurento client, okay? So at the browser, you have an object which is the Kurento client, and this Kurento client is acting as a proxy to the media server. So in that object, you are going to have different primitives and different data structures which you can use for communicating with the media server. So when you instantiate the Kurento client, you just need to provide where the media server is located. The communication with the media server is made through WebSockets. There are other different types of or different protocols supported, but I can discuss this with the people who really want to make applications, but the most simple way is through WebSockets, and then you just provide the location of the media server, the IP, and the port where you have installed the media server. And once you have this Kurento client created, you just need to create a media pipeline. Which is a media pipeline? A media pipeline is a chain of media objects. So somehow it is the container of the chains of the media object. So the first thing is to create the media pipeline. It's somehow saying to the media server, get prepared because I'm going to create a chain of media objects right now. Okay. So I create a media pipeline just by invoking. Yeah.
Maybe you could change the resolution.
Yeah, sure. Sorry.
Nothing to see from here. So what I don't know.
Right now, better. Okay, so I was basically explaining you that we can use this create method for creating a media pipeline. So basically, the API makes possible to ask for the creation of things at the media server side. Okay, so I just say create, and I create whatever I ask for. In this case, I'm creating that media pipeline, something which is going to hold, to store the chain of media elements. And now, once I have the media pipeline, this guy, I can ask the media pipeline for creating the different elements I want. Given that I just want the capability of sending and receiving WebRTC streams, I say pipeline create a WebRTC endpoint, which is the guy capable of sending and receiving WebRTC streams. Okay. And once I have the WebRTC endpoint, I need to ask this endpoint to start the communication with the browser. And here is the part where a thing which is a little bit obscure happens. This, which is obscure, is not obscure because of Kurento, it's obscure because the way in which WebRTC has been decided. So basically, when you establish a communication between two endpoints, between an emitter and a receiver, when you want to establish this communication, the two entities, the two endpoints, need to negotiate how the communication is going to take place. They need to agree on what are going to be the codecs they are going to be using, what are going to be the protocols they are going to be using to communicate, in which ports they will be sending the information, in which IP addresses they will be sending the information. Okay, so somehow there is a need for negotiating how the communication takes place. Then this negotiation takes place through the change of something called SDPs. SDPs is something which is standardized in an RFC, and which means Session Description Protocol. S from session, D from description, and P for protocol. Okay, so basically I need to exchange two SDPs. The browser needs to generate an offer, an SDP, which is the offer, and the media server needs to receive that offer and generate an answer. Okay, so basically this is what is happening here. To the WebRTC endpoint, I'm asking him to process the offer of the browser. This is the offer which the browser generated. I'm going to show you later how the browser generates this offer. But basically here, if you print this into a log, you will see that it is a very long string having a lot of information related to codec information, ports, IPs, and things like that. Okay, and basically the media server says, okay, this is your offer, I process it, and I generate an answer. And once I generate the answer, I can give the answer to the browser. I can say to the browser, this is your answer. Okay, so the code for making the negotiation is this one, but with just that negotiation, we will have a WebRTC endpoint capable of exchanging media and basically capable of receiving media from the browser. But what I want is that the media generated by the WebRTC endpoint, I want that media to be fed into the own WebRTC endpoint. So somehow I need to ask the WebRTC endpoint to connect its source to its sink so that the media it receives is fed into the media it is sending. And this happens just through a connect primitive. This is happening here, and I can ask to the WebRTC endpoint to connect to itself. Connect means connect your source with the sink of whatever I give you as a parameter. Okay? So basically, summarizing, I need to create a pipeline, to create a WebRTC endpoint, to negotiate the SDP with the WebRTC endpoint, and to connect the WebRTC endpoint with whatever I want to give the media to. which in this case is the WebRTC endpoint itself. Okay, so that's all. That's all we need for making this simple example. Okay. If you want to take a look to the code itself, this is the code of the application. We can put it bigger. So the application has two parts, an HTML part and a JavaScript part. In the HTML, the most relevant part is that we have a couple of video tags, because WebRTC streams can be visualized in the browser using video tags. So I just need to put into my web page two video tags. One for showing the local stream, that means one for showing whatever the webcam is catching, and one for showing whatever I'm receiving from the media server. So I have here the first video tag, and I've got here the second video tag. So two video tags. And the rest is just code for putting the buttons and for putting the logic. And if you take a look to the JavaScript code, you will find that basically when the application starts, I just get a reference to these two DOM objects. And here I'm using the Kurento APIs for asking the browser to generate an offer. Sorry. So basically, this means this WebRTC peer represents the WebRTC capabilities into the browser. So I'm just saying, browser, start sending and receiving media, and give me the offer in this callback. This is what this line is meaning. And if we look to the callback, this is what happens when the browser generates the offer. What happens? Basically, I create a Kurento client. This is what we have shown before. I ask to create a media pipeline to the Kurento client. We can put it bigger. I ask the pipeline to create a WebRTC endpoint, and I made a negotiation. Okay, given that everything is executing at the browser, I've got here the offer, the SDP offer generated by the browser. And once that I have the answer, I can tell the browser, process this answer, which closes the negotiation. And when I close the negotiation, I just need to connect the WebRTC endpoint to itself, and I close the loopback. The media is going to the media server and coming back to the media server. Okay. So it seems complex, but it is not very complex. And the advantage is that it is always the same thing. Independently on the application we are creating, it is always the same. We just need to instantiate whatever we need at the media server at Kurento, just by making create pipeline and asking things to the pipeline, create this element, create this element, create this element. I connect them in the way I want, and I just need to make the SDP negotiation, which is the obscure part. I just need to recover the SDP from the browser somehow and give the SDP to the WebRTC endpoint to get the answer. And when I get the answer, I can give it back to the browser. Okay? So this is our first example. And this is somehow the architecture of this example. Basically, you have the application code, which is what I have shown you, which is consuming two APIs. One API, which is called Kurento utils, which is somehow abstracting the WebRTC complexities of the browser. And another API, which is called Kurento client, which is communicating with the media server. So your work is here at the application code. Okay. This is the call flow. I can analyze it with people who are going to work really with Kurento. And just to conclude, if you want, given that we have some minutes, no, we don't have some minutes. Do you want to see a demo, fast demo? Yeah. So fast demo, and we go to lunch. Then here I have my code. Let's put it in bigger. Here I have my code, okay, which is the Java, the JavaScript and the HTML. The APIs have somehow been installed into FIWARE. Do you know about FIWARE? So that you don't need to download them. You just need to make FIWARE install. When you obtain the code, you make FIWARE install, and the APIs are all of them are downloaded. Okay. So once you make FIWARE install, you can just launch the media server. I've got a media server here in a virtual machine running Ubuntu 14.04, but you could have your media server running at the FileLab or wherever you want. And once we have this, we open a browser, and we can start the application just by executing a very simple server. Let's put it like this. Okay. So we have a very simple server, node server, which is called HTTP server. And with this should be enough. Yeah. So this is the application. If you want, we can open the console just for checking the logs. And here I have a video tag. This is a video tag for showing the local stream, and this is a video tag for showing the remote stream. When I press start, first of all, the browser asks me for sharing my webcam. This is somehow mandated by the WebRTC technology, because they assume that opening the webcam is something that the user needs to authorize explicitly for security reasons, of course. So I click on allow, and right now the negotiation is happening. The media server and the browser are changing the SDPs, and something happened. Okay, given that we want to go to lunch, we are not going to spend time with this. I will show you the demo during this afternoon, promised.